Okay, now we're going to be talking about some exponential integration. This is the base e that we're dealing with. And recall that the integral of e to the u du is just e to the u plus c. Now we're going to take the u substitution and kind of do the chain rule in reverse, because that's what this is. So let's take a look here. And I'm going to see that u in this case is going to be my exponent there, negative 8x. So my du will be negative 8 dx. And so I need to think about this. What am I missing? Well, I'm missing a negative 8. So I'm going to make that happen. I'm going to write out a negative 8. I'm going to multiply it there. But by consequence, I need to write a negative 1 out of 8 on the outside. Okay? And so I have this 2 that I'm going to migrate across that integral symbol. And I'm going to say, well, I have negative 2 over 8, right? The integral, I have a negative 8e to the negative 8x dx. And now let's figure out what I've got left here. This right here represents my u, and this negative 8 dx represents my du. I can reduce the negative 2/8 that was outside, and I can write it as negative 1/4, the integral of e to the u du, and then it fits this form over here. So all I have to do is say, well, then I have negative 1/4 e to the u plus c, and then I can back substitute negative 1/4 e, and in this case it's to the negative 8x plus c, and there is my answer there for this integration. Let's take a look at another. This next one's kind of interesting now that I'm looking at it. So let's take a look. I've got 6e to the, I believe it's 6 sine of 3x, and then of course dx, and then it's all going to be placed over the secant of 3x. Okay, so this one is a really nice example because it makes use of this kind of u substitution, but then you also have to know some trig identities. So let's think about what it is we need to recall here. So here's what I want you to recall. All right, I can see this, okay, because I'm looking ahead, okay? I see it already playing out. But I see the cosine of x is the reciprocal identity for 1 over the secant of 3x, or 1 over the secant 3x, I believe is, I'm sorry, not 3x, 1 over the secant of x. The 3x is going to come into play right now in this problem. So 1 over the secant is the cosine. And again, I'm looking ahead, and you'll see right now what I'm talking about. If u is this guy right here, okay, and I'm going to stick with my convention of circling it in red. Let's call this u. So then what is du? So 6 sine of 3x, all right? I'm going to take the derivative. Of course, I've got my 6 there. Derivative of sine is the cosine of 3x multiplied by 3, the derivative of the inside, and then dx. So that's going to work out to be 18 cosine of 3x dx. Okay, so nothing to it there. All right, and it's actually really nice. All right, now you don't necessarily have to multiply the 6 and a 3, and you're going to see that right now. But the reason why I made you think about this very famous trig identity here is because we should see that we've got our u. Where's our du? Well, we need a cosine. So what we're going to do is bring this back up, okay? We're going to bring it up. So let's just adjust here, right there. It's good. All right. And let's see what we've got. So I'm going to have, oh, what am I missing? Let's see. I've got 6. I need a 3. I need a 3 for sure. Let's make the 3 happen. Put the 3 there. And then I'm going to have to write a 1/3 on the outside. Because if you see here, I've got the 6 I just need this missing 3. That's why you don't necessarily have to multiply. So let's take a look. I've got 1/3 on the outside, and then I've got this integral. I've got 3, I've got times 6e to the sine of 3x, and it's actually 6 sine of 3x now that I look at it, dx, and then multiplied by, and so I'm going to actually move the dx for a second there, cosine of 3x, because the secant moves up, and there's my dx. Okay, cool. Now we're going to do our ring. This right here is u, and then if I look here, 6, 3, cosine 3x, there's my 3, there's my 6, there's my cosine 3x, and my dx. There we go. So it looked really complicated, looked actually quite nasty. All right, 1/3 on the outside, the integral, the rest we ringed. We put a ring around it, so we've got e to the u du. It fits the form. We know this integral already. It's 1/3 e to the u plus c, and we back substitute 1/3 e, and u was 6 sine of 3x plus c, and nothing to it there. Really nice. A really nice integral. Again, making use of u substitution really beautifully here. I think we can do a couple more examples in this video. So let's go ahead and take a look at another. In the words of a famous DJ, another one. All right, you figure out who that is. I don't own the rights to that phrase, that catchphrase. All right, let's see. We have the integral, and I'm going to call this one number 7. The integral of 10e to the square root of 5x dx over 2 square root of x. Okay, so let's see what we've got here. What do we pick for our u? Well, this right here looks really nice to pick for u. So u equals the square root of 5x, which we're going to call 5x to the 1/2 power. And now we take our derivative. We have 1/2 that comes down. 5x stays on the inside. 1/2 minus 1 is a negative 1/2, multiplied by 5, the derivative of the inside. And let's see what that looks like when I clean it up. It becomes 5 over 2. The negative 1/2 power means a square root in the denominator, so square root of 5x. And then, of course, dx. So we'll write the dx right there. All right. So I'm seeing, do I have a 5? Well, let's think about this 10. It is 5 times 2. Okay, so I have the 5 there on the top. I'm going to check that off. I do have the 2 in the denominator. I have the square root of x. What I am missing is this square root of 5. So I'm going to, once again, make it happen. All right. So I do that by multiplying by a square root of 5 over the square root of 5. Okay, and really the square root of 5 should have gone in the denominator first, but that's okay. And so we can migrate some stuff across, okay, to clean this up. So let's see, what is it that I need? Okay, let me put a ring around it here first. I need the 5 on the top. I need the square root of 5, I need the 2, I need the square root of x, and I need the dx, all to represent my du. So we should start seeing what goes outside and what goes inside. Okay, if you see what's outside, it's a 2 square root of 5, the integral, okay, and it's now going to be of e to the u du. Just like that, okay? It almost seems like everything disappears, okay? So that is pretty straightforward now. It's just 2 square root of 5 e to the u plus c, and we back substitute. 2 square root of 5 e to the square root of 5x, that was our original u, plus c. And we have that right there. All right, let's take a look at another integral, the last one for sure. This will be the last one for this video. All right, let's see here. This one's rather nice. We've got an integral x to the fourth e to the negative x to the fifth power dx. Okay, so again, another u sub. All right, we're going to pick u to be this negative x to the fifth. Okay, and our du is pretty simple. It's negative 5x to the fourth dx. So I've got my x to the fourth. I'm missing the negative 5. I make it happen. Negative 5 right there. By consequence, I need a negative 1/5 on the outside. Okay, so let's see here. This right here then represents my du. And now I'm ready to integrate. And it's very simple. All right, so I have negative 1/5, the integral of e to the u du plus, I'm sorry, negative 1/5 e to the u du. Okay, I was jumping the gun there. All right, but it's no different. All right, negative 1/5 e to the u plus c. That's where I was going with this anyway. What is it? Negative 1/5, and then I just back substitute my negative x to the fifth power plus c. And again, a really nice and simple indefinite integral rather for an exponential function. So again, this video might have been rather long-winded, but you definitely have some solid examples now to go by for indefinite integrals if you're integrating exponential functions like this. So, as always, I hope this video was helpful, and remember, like and subscribe.